Hey everybody, so we're back now with angular momentum part two, and we are going to look at this case, the applying an angular impulse or applying Newton's second law to angular momentum. And so angular impulse is what we're going to take a look at. So just to remember Newton's two laws, or Newton's one law, his second, F equals ma, where the analogous torque equals I alpha. And so what we'll do is we'll actually start with the torque equals I alpha, as well as alpha is equal to change in omega with respect to time. Right, this is how we got impulse for um, linear. So we can combine these two and we can actually say that torque is equal to I times change in omega with respect to time. All right, we can rewrite this this kind of whole thing, sorry about that, as torque delta t, change in time, is equal to I delta omega. Now we've seen this before. This expression right here, right, is just our change in angular momentum. I omega is angular momentum, so I delta omega will be change in angular momentum. And this over here is therefore our angular impulse. No special variable for it. All right, we can write this as delta L is equal to torque delta T. Okay, fairly common expression for it. And that's why it's important to differentiate how you write your torque and your times and your temperatures and all that good stuff for when you have equations that have them all in it. Then you can kind of keep everything straight. So we can move ahead to some problem solving. All right, in a light wind, a wind turbine experiences a constant torque of 240 newtons meters. The windmill's initially at rest. That's key, right? Because if this is at rest, it tells us right away that our initial angular momentum, L initial, is equal to 0, right? What the angular momentum is later. So we know that change in angular momentum is going to be a torque applied over some time. And we know that our initial angular momentum is 0. So we can rewrite this as L F minus Li is equal to some torque times a time, where this is going to go up to 0. And so in this case, pretty simple to solve. LF is going to be 240 Newton meters applied for 3 seconds. All right, give you a second just to solve that through. All right, and your final angular momentum should have been 720, right? And we can use all sorts of stuff. So this could be a Newton meter second as well. That's a fun little unit.